going to find a power series for sine x. So we'll assume sine x equals a plus bx plus cx squared, etc. And obviously we need to find the constants a, b, c, d, etc. First step is to put x equal to 0. So we get sine 0 equals a, and all the rest are 0. So in fact a is 0. Step 2 is to differentiate equation 1. So we differentiate sine x, we get cos x here equals b plus 2cx, etc. Then we put x equal to 0 again. So we get cos 0 is 1, and this bit stays at b, and all the rest are 0. So now we have b equals 1. Step 3, we differentiate equation 2. So we differentiate cos and we get minus sine x, and we get 2c. Then we get 6dx, etc. like this. Then we put x equals 0 again, and we get sine negative sine 0 is still 0. That becomes 2c, and all the rest are 0 again. So c is 0. Step 4, we differentiate equation 3. And so we get minus cos x equals 6d plus 24 fx, etc. like that. Then we put x equal to 0 again. And we get minus cos 0 is negative 1. And that is equal to 6d, and all the rest are 0. So d is in fact negative 1/6. Now it's convenient to call this negative 1 over 3 factorial, as we will see later. Step 5, differentiate equation 4. So differentiate minus cos, and we get sine x. Differentiate this, and it's gone. Differentiate this, we get 24f, and the rest of the terms here. And then we put x equals 0 again. We get sine 0 equals 24f, and all the rest are 0. And so f is 0 too. Now step 6, differentiate equation 5. And then with this we get cos x again equals 120g plus 720hx, etc. Put x equals 0 again, and we get cos 0 is 1 equals 120g. Therefore g is 1 over 120, which nicely is 1 over 5 factorial. Step 7, differentiate equation 6. And we get negative sine x equals 720h, and all the rest. Put x equals 0 again, and we get 0 equals 720h, so h is 0. Step 8, differentiate equation 7. And we get negative cos x equals 5040k, and the other terms. Put x equal to 0. Cos 0 is 1, so this is negative 1, equals 5040k. And k is negative 1 over 5040, which is actually negative 1 over 7 factorial. So this is what we found. We found that a and c and f and h were all 0, like this, leaving this series here, sine x equals bx, dx cubed, g, x to the 5, etc. And we found the values of b, d, g, and k, like this. So this produces sine x equals this very special series. Now obviously this pattern with the factorials continues, and this is the usual form of the series for sine x.